we were just, it said, simplify the trig identity. That means you are not given the answer. You have to just know when to stop. Now what 7.2 does is it's almost like it goes backwards and it says it's going to just ask you to verify, so it is going to give you the answer. You can work from left to right or right to left. I don't care, meaning, but I would always take the uglier side and make it prettier. It's hard to make something pretty uglier, you know, but to simplify something, taking something that's not as simplified and get it to the simplified side. Now remember, you're not allowed to move across an equal sign. You just know that your answer needs to end up to be sine squared. So let's just practice a few quick couple things. What would you change this to be? On the left. So the top you just said was tangent squared theta? Yeah. So we have tangent squared theta over secant squared theta. Then what would you do? Okay, you just said sine of theta over cosine of theta. Cosine squared, I should say. Okay, 1 over cosine squared theta. Okay, so then that's cosine squared theta over 1, which those divide out, so we get sine squared theta, and then your work is your answer, right? Okay, moving on to the next one. Just a couple quick things. This is going to be done here soon. All right, so if you were, yes. Okay, so if you were looking at this one without the answer here, you guys, what you would say is, this is 2 terms. I need to make this 1 term, so I need to get a common denominator. Does that make sense? So this one we're going to times by 1 plus sine theta. This one 1 minus sine theta. So then the whole point of doing that is so that you can combine the numerator. So you distribute your 1 through, and combine like terms. So we have 1 plus sine theta. Then we have plus 1 minus sine of theta. And then that's all over the common denominator of 1 plus sine theta, 1 minus sine theta. You're not going to be that person that divides across addition signs, right? And just undoes what you just did? Okay, don't do that. So now, let's combine like terms on top. What do we have? 1 plus 1 is 2, because these go away. So we have 2 over. And then if you guys have conjugates, shouldn't you multiply them together? Yes. So that'd be 1 minus sine squared theta. So then you have 2 over. Okay, good. And then it would be the most simplified to not have fractions, so your final answer would be 2 secant squared theta. Isn't that the same thing as 1 over cosine squared, everybody? So that's when you would know when to stop. Now, I know that's right because that's also given. But I'm just trying to help you see it's harder on the test for people to not be given the answer and know when to stop. Okay, next one. Just a reminder. All right, looking at this one, many ways to tackle it. What would you say this would be? What would you do personally?
Minus 1 would be sine squared. And then tangent squared plus 1.
So that's secant squared x?
Yeah, and then that one's sine squared x.
You're saying that that is sine squared x?
Yeah.
All right, we got to make sure we're careful. That's not actually sine squared x. That's negative sine squared x.
Oh, wait, right, yeah.
So just a reminder, yeah, so you could write down the original, right? So like sine squared x plus cosine squared x equals 1. And then you'd say I need it to be cosine squared minus 1. So I'd subtract 1 and subtract sine squared over to get it in the correct order. Does that make sense, everyone?
Yeah.
Okay, cool. So now we're good because now from here you would say secant is... So you have 1 over cosine squared x times by negative sine squared x, which is sine squared over cosine squared, which is, that's negative tangent squared x. Okay, good. Doing good. Hopefully you guys are seeing, like, really, identities are not bad, right? They're kind of fun. They're not bad at all. Okay, what would you do here, personally, if it was you? So you'd call that sine of x over cosine x, somebody would, anyways. Okay, then what would you do? So you do sine x, cosine x, cosine x. So then we would have sine squared x plus cosine squared x over sine x cosine x. So 1 over sine x cosine x. Good, 1 1 over sine of x times 1 over cosine of x.
Would be secant times cosecant.
Okay, good. You guys are doing really good. Alright, so just a reminder, we did go over this last time. If I said to you, given, here's an answer, you'd say, but that answer is not considered simplified because I have a radical on bottom. When you have two terms and you have a radical, remember to get rid of it, you multiply by the conjugate, right? And so then we'd end up here at a more simplified answer technically. Well, this same idea works in this situation. So look, 1 minus sine of y, we would rather not have anything in the denominator, correct? Meaning we would rather not have sine in the denominator, so we'd multiply by the conjugate. Now notice a lot of people try to go this way over this way. I think that's going to be harder than taking this side and going this way. Because technically this is less simplified, right? Because fractions. So you would now notice, you would say, okay, I'm going to multiply by 1 plus sine of y. Now I wouldn't distribute, sine of y. I wouldn't distribute unless I end up wanting to in the end. So unless nothing simplifies, I would leave it as factored, but you might end up multiplying it out. So for now, let's leave it factored. Cosine of y times by 1 plus sine of y. Now on bottom, don't I get 1 minus sine squared y? So then I have cosine of y times 1 plus sine of y over cosine squared y. So then don't those divide out? So then I have 1 plus sine of y over of just cosine of y. Have we reached our answer yet? So you said you would split it up as 1 over cosine of y, because we haven't reached our goal yet, plus sine of y over cosine of y. Yeah, but is that going to help us get to reaching our goal? It is?
Yeah.
Oh, I'm looking at, what the freak, I'm looking over here, I'm like, I was like so confused. I'm like, you guys were trying to get here, like that's not helping. I see what you're saying. So then that's secant y, sorry, blonde moment there. Tangent y, and that's what we were trying to get to. Okay. Yeah, blonde moment. All right. We're actually almost done with the lesson. Stick with me. 2 more examples. That's it. Okay. So which side do you prefer, which side do you think's less attractive? The left? Okay, so then how would you tackle it, the left? That's one way of doing it. Any other ideas too? It has to be squared. The conjugate, guys, if you have 2 terms, right, in a denominator, a lot of times it's helpful to do the conjugate. Not that I'm saying that your way would have been wrong or anyone else's way would have been wrong. I just think this is going to be the easiest, the conjugate idea. So 1 minus cosecant theta, 1 minus cosecant theta. So then I'm going to leave it I'm going to leave it not distributed. I'm going to leave it factored for now. Now what's on bottom? 1 minus cosecant squared theta. Yeah, so you guys got to be really careful once again. It actually turns into negative cotangent squared, doesn't it? Look at your trig identity on your paper if you need to. So that's negative cotangent squared theta. So then what do we get? This divides out. Don't we have a negative 1 on bottom? So let's write down the original Pythagorean identity. What is it? Oh, are you sure? You see it? If you write down the original and then get it in the correct order, then it would be the 1 minus cosecant squared, then it would be negative cotangent squared. So then we have this, guys, 1 minus I can't talk and write that at the same time, as you can tell, like every time I almost write. All over negative 1. So guys, look what this is. Divide both of these by negative 1, wouldn't you? So then that'd be negative 1 plus cosecant theta. Have we reached our goal yet? No. Well, what is that? That's negative 1 plus 1 over sine of theta. And then if we were going to put that together, we would need a common denominator, wouldn't we? So we times by sine. So then you'd say that's negative sine of theta plus 1 over sine of theta. Is that our same answer? Yes, right? So Okay, good. Last example. Actually, I think that was the last one. Let's see. I believe I don't know what is wrong. Yep, that's the end. The rest of the time is yours. Work on 7-2, and then I want you to do like 5 to 10-ish more on that white paper. So you guys have the whole time to get really, really good at those identities on that white paper in 7-2.